The market has spent the last decade worshipping the 7.3-liter Power Stroke as an unkillable god, but they are blindly driving these trucks straight into a mechanical graveyard. You see a rusted bed and a six-figure odometer and think you found a million-mile tank for $6,000. What you actually bought is a ticking time bomb engineered by corporate cost-cutters who hid fatal design flaws beneath 920 pounds of cast iron. Everyone tells you this Navistar block is commercial-grade perfection. They are lying to you. No engine is unkillable when it relies on a hyper-complex hydraulic system that uses dirty engine oil to smash fuel into the cylinders at 21,000 pounds per square inch. The industry wants you to believe that regular oil changes are enough to save you. It is a fairy tale. If you do not know the exact engineering blind spots that Ford left behind, your cheap auction prize will cost you 5 figures in catastrophic failures before you even hook up a trailer. Point 5. The cavitation erosion black hole. You look at a 7.3 block and see massive cast iron walls. You think it is indestructible. You are wrong. While you drive down the highway, your cylinder walls are being eaten away from the outside in by a silent, microscopic killer. Every time a diesel piston fires, it creates a massive vibrational shock wave. This force makes the cylinder wall flex and vibrate inside the coolant jacket. This rapid movement creates microscopic vacuum bubbles in the coolant. When these bubbles collapse against the hot iron wall, they implode with a violent force of over 15,000 pounds per square inch. This process is called cavitation erosion. It acts like a tiny, high-powered jackhammer. Over time, it drills pinholes right through the cylinder wall. One morning you will start your truck, and coolant will flood the cylinder, causing instant hydrostatic lock. Your engine is now a 920-pound piece of scrap metal. Manufacturer defaults failed you here. Ford filled these engines with standard green coolant that offered zero protection against this harmonic destruction. They did not care what happened to the block after the warranty expired. A remanufactured long block costs $7,000, plus another $3,000 in labor to swap it. That is a $10,000 disaster compared to a $40 bottle of supplemental coolant additive. The immediate fix. Stop driving the truck today and test your coolant. Buy a pack of fleet testing strips to check the supplemental coolant additive, SC6 or DCA4 levels. If the levels are low, add a bottle of Motorcraft VC8 formulation immediately. For permanent protection, drain the system completely and upgrade to an extended life coolant, ELC, that meets the EC1 specification. This eliminates the need for additives entirely and seals the iron against bubble implosions. Point 4. The fuel rail fire hazard and the poisoned harness. Look closely at the top of your engine. Underneath the plastic cover lies a design flaw that combines high-voltage electricity with hot diesel fuel in the worst way possible. The 7.3 uses an under-valve cover harness, UVCH, to supply power to the glow plugs and electronic injectors. This harness passes directly through the valve cover gasket. This means delicate plastic connectors and wiring insulation sit in a constant bath of boiling engine oil. Over time, the plastic clips degrade and soften, the locking tabs release, and the electrical connector backs out of its socket. This creates a partial disconnection. When 115 volts of injector signal cross that loose connection, it creates massive electrical resistance and extreme heat. The harness melts. It shorts out your injector signals, causing an immediate dead misfire. Even worse, the glow plug wires can short out and send raw voltage directly into your computer, frying the powertrain control module instantly. A towed truck and a fried PCM will cost you $1,200 at a shop. Fixing the harness before it melts costs less than $50 in your driveway. The immediate fix. If your engine stumbles or feels like it loses half its power instantly, pull the valve covers. Inspect the internal plastic harness connectors. Do not buy a cheap auto parts store replacement harness. Purchase the updated OEM Ford kits or install the quarter trick, sliding a precisely ground coin under the locking tab to lock it mechanically into place so it can never back out again. 3. The fuel bowl heating element short circuit. Imagine driving 70 miles per hour down a dark highway in freezing weather with a heavy trailer behind you. Suddenly, the engine dies completely. The dashboard goes black. The power steering vanishes. You pull over, cycling the key. The engine cranks vigorously, but it will not fire. You assume the high-pressure oil pump died or the injectors failed. You are wrong. You were stranded by a cheap $3 piece of wire inside your fuel bowl. Ford placed an electric heating element inside the fuel filter housing to keep diesel fuel from gelling in sub-zero temperatures. This heating element sits submerged in raw fuel. Over decades of vibration and heat cycling, the ceramic insulation on this element cracks. The bare wire makes contact with the metal housing of the fuel bowl. This creates a direct short to ground. The moment it shorts, it instantly blows fuse 22 in your underhood junction box. Here is the corporate design failure. Ford wired the fuel bowl heater on the exact same electrical circuit as your powertrain control module. When the heater shorts, it kills the computer. The truck thinks it is being stolen or destroyed, so it shuts down the entire injection system instantly. A tow truck operator will charge you $300 to pull you off the highway. A clueless shop will charge you $500 trying to diagnose a dead computer. The real fix costs nothing, the immediate fix. If your truck dies out of nowhere and will not restart, open the fuse panel and check fuse 22. If it is blown, walk to the front of the truck. Locate the electrical connector on the back of the fuel filter bowl and unplug it completely. Replace the blown fuse with a fresh 30-amp fuse. The truck will start immediately. You do not need the heater unless you live in the Arctic Circle. Leave it unplugged permanently. 2. The up-pipe pressure bleed. You bought a diesel to tow. You expect massive torque at 15,600 RPM to pull trailers up steep grades without breaking a sweat. But your truck feels sluggish. Your exhaust gas temperatures climb dangerously high, and you hear a distinct hissing sound under load. You assume your turbocharger is wearing out, or your injectors are tired. You are looking in the wrong place. Your engine is losing its driving force through a series of primitive, leaking metal joints behind the block. The 7.3 uses cast iron exhaust manifolds that feed into steel up pipes. These pipes carry hot exhaust gas up into the collector to spin the turbocharger. To allow for engine expansion, Ford used simple crushed donut gaskets at the pipe joints. This design is a total failure. The constant expansion and contraction of the exhaust system crushes these gaskets into dust. Exhaust gas escapes into the atmosphere before it ever reaches the turbo turbine wheel. This means your turbocharger cannot spoil up efficiently. You lose substantial boost pressure. Because the turbo cannot force enough air into the cylinders, the engine runs rich, burning excessive fuel and driving exhaust temperatures past 2300 degrees Fahrenheit. This extreme heat warps valves and cracks pistons. You are burning an extra $150 in fuel every month while actively destroying your internal engine components. The immediate fix: pop your hood and look behind the engine intake. Look down at the collector where the up pipes meet the turbo. If you see heavy black soot caked on the firewall or the pipes, your gaskets are blown. Throw the factory design in the trash. Order a set of aftermarket bellowed up pipes. These use flexible braided stainless steel bellows instead of crush gaskets, sealing the exhaust completely and restoring your lost boost. 1. The low-pressure oil pump starvation. The entire HEUI system depends on high oil pressure to function. You know this. But you are likely ignoring the foundation of the entire system. The low-pressure oil pump mounted on the front of the crankshaft. The high-pressure pump cannot generate 3,000 psi of pressure out of thin air. It relies on a steady, unaerated supply of oil delivered by a basic gerotor pump at the front of the engine. If this low-pressure pump loses efficiency, the entire injection system starves. The factory pump uses an aluminum housing with steel gears. Over time, road grit and microscopic metal particles bypass your oil filter and score the soft aluminum housing. This widens the clearance between the gears and the pump wall. When the engine is cold, the thick oil hides the wear. But once the engine reaches full operating temperature, the hot, thin oil slips past the wide gear clearances. Your low-pressure oil volume drops off a cliff. The high-pressure pump begins to cavitate, creating tiny air bubbles in the oil channels. Air compresses. Oil does not. The air bubbles cause erratic injector firing, violent idle vibration, and severe power loss under heavy load. You think your expensive injectors are failing, but they are simply being starved of fluid. Replacing 8 injectors will cost you $2,000 in parts alone. Replacing the worn pump costs less than $100 and protects your entire hydraulic system. You think you know how to diagnose this, but the worst revelations about what happens inside the oil reservoir are still hiding right beneath the surface. Say zero. The oil reservoir drainback trap, that low-pressure pump failure, feeds directly into a hidden reservoir design flaw that will destroy your top-end components before the oil pressure gauge on your dash even registers a problem. The high-pressure oil pump, P, sits in the valley of the engine, but it does not pull oil directly from the pan. Instead, it draws from a small cast iron reservoir mounted on top of the front cover. This reservoir must remain completely full at all times, so the high-pressure pump has an immediate supply of oil upon startup. Inside this reservoir, Ford engineered a simple anti-drainback check ball and seat mechanism. The engineering intent was to prevent the 15 quarts of oil in the upper engine from draining back down into the oil pan when the vehicle sits overnight. Over decades of thermal cycling, the spring behind this check ball weakens, or debris from a degrading oil filter sticks to the seat. When you turn the truck off, the check ball fails to seal. Slowly, over several hours, every drop of oil drains out of the top reservoir and drops back into the oil pan. When you turn the key the next morning, the high-pressure pump is spinning dry. It takes up to 10 seconds of continuous engine cranking for the low-pressure pump to fill that reservoir back up. During those 10 seconds, your high-pressure pump is cavitating, generating intense metal-on-metal friction, and sending microscopic steel shavings directly into your expensive fuel injectors. You will notice the truck takes longer and longer to fire on cold mornings. You will blame the starter, the batteries, or the glow plugs. A new high-pressure pump and 8 contaminated injectors will easily run you $3,500 at a diesel specialty shop. Inspecting and restoring this reservoir system takes an hour of labor and costs less than $20 in seals. The immediate fix. Before you waste money replacing your starter or batteries for a hard start condition, perform the reservoir check. Let the truck sit overnight. Before cranking it in the morning, remove the small inspection plug on top of the H-pop reservoir using an Allen wrench. Stick a clean zip tie down into the hole. The oil level should be within 1 inch of the top. If it is empty, your check ball is leaking. Remove the reservoir cover. Clean the check ball seat with brake cleaner, and replace the check ball spring and O-ring with a heavy-duty Viton kit to secure your top-end oil supply. 1. The injector cup coolant contamination. You check your cooling system reservoir and notice the fluid looks dark, muddy, and smells like a fuel station. Or worse, you pull your oil dipstick and see a milky, light brown sludge. The internet forums will immediately tell you that your head gaskets are blown and that your engine block is warped. They are completely wrong. The 7.3-liter block uses a robust 6-bolt per cylinder design that almost never blows a head gasket under factory or moderate tuning levels. Your real enemy is a thin sleeve of stamped brass hidden deep inside the cylinder head. Because the fuel injectors sit directly inside the cast iron cylinder head, they need to be cooled. Ford isolated the injectors from the surrounding engine coolant jackets by pressing thin brass sleeves, called injector cups or sleeves, into the injector bores. These brass cups are held in place by a thin layer of high-temperature retaining compound. Over 20 years of aggressive thermal shock, going from sub-zero winter temperatures to 1,200-degree exhaust pulses, the brass constantly expands and contracts at a different rate than the surrounding cast iron head. Eventually, the brass develops microscopic hairline fractures, or the retaining compound turns to dust. Because fuel pressure inside the injector body is higher than coolant pressure when the engine runs, raw diesel fuel is forced straight through the cracked brass cup and into your engine's cooling system. When you turn the engine off, the residual cooling system pressure reverses the flow, pushing corrosive green coolant back through the crack, washing away the lubrication on your injector tips, and draining down into your combustion chambers. If you let a shop misdiagnose this as a blown head gasket, they will charge you $4,000 to pull the heads and replace parts that were completely fine. The actual fix requires zero head removal and costs around $150 in parts. The immediate fix. If you find fuel in your coolant, do not pull the engine heads. Remove the fuel injectors and use a dedicated injector cup removal tool to pull the old brass sleeves out of the cylinder heads. Clean the cast iron bores meticulously with a wire brush and acetone. Apply a high-strength green retaining compound, like Loctite 620, to a new set of OEM brass cups and use the installation tool to swage them firmly back into the heads. Allow 24 hours for the compound to cure before refilling the coolant too. The oil pan corrosion death sentence. You find a truck with a pristine interior, perfect service history, and a dead silent cold start. You look underneath and see a steady drip of engine oil coming from the bottom of the oil pan. You think nothing of it. It is an old diesel, and old diesels leak oil. You assume you can just swap out the oil pan gasket over a weekend. You are walking into a mechanical nightmare. That minor rust on the oil pan is the single most common reason perfectly healthy 7.3 engines get sent to the scrapyard. The engineering failure here lies entirely in Ford's manufacturing process. The oil pan on the 7.3 is made of stamped steel, and the factory paint coating was incredibly thin and prone to microfractures from road debris. Worse yet, the engine design does not use a traditional rubber or cork oil pan gasket. From the factory, Navistar sealed the oil pan directly to the cast iron engine block using a high-grade gray silicone liquid gasket, because road salt and moisture get trapped in the lip where the pan meets the block. The stamped steel begins to rust from the outside in. The metal flakes away in layers until it becomes paper-thin. Eventually, the pressure of 15 quarts of oil punches microscopic pinholes right through the metal. Here is the trap. You cannot change this oil pan with the engine inside the truck. The massive front crossmember of the Ford frame sits less than an inch below the oil pan. To remove the pan, you must completely unbolt the motor mounts, disconnect the transmission, and use a heavy engine hoist to lift the entire 920-pound engine completely out of the chassis. If you take a leaking oil pan to a diesel repair shop, the labor guide specifies 12 to 15 hours of work. That turns a simple rust pinhole into a $2,500 to $3,000 repair bill, often matching or exceeding the actual auction value of the truck. The immediate fix: if your oil pan is rusty but not yet leaking, scrape it clean with a wire brush down to bare metal, apply a rust converter primer, and coat it with a heavy layer of rubberized undercoating. If it is already weeping oil through pinholes, do not pull the engine yet. Drain the oil and clean the leaking area completely with brake cleaner until it is bone dry. Rough up the metal with 80 grit sandpaper and apply a specialized multi-layer epoxy patch kit designed for fuel and oil tanks. This external patch will buy you years of service and save you thousands in engine pulling labor costs. 3. The mechanical fuel pump cam lobe destructor. If you are hunting for an early generation old body style truck, built between 1994 and 1997, you are dealing with a mechanical component that modern trucks completely abandoned. Instead of an electric fuel pump inside the gas tank, these early trucks rely on a dual-stage mechanical lift pump mounted directly in the engine valley behind the turbocharger. This pump is driven mechanically by a short steel plunger rod that rides directly on an eccentric cam lobe machined onto the engine's main camshaft. Every time the camshaft rotates, it pushes the plunger up to pump fuel to the injectors. The engineering flaw is a combination of modern fuel chemistry and material fatigue. Modern ultra-low sulfur diesel, ULSD, has significantly less lubricity than the high-sulfur diesel fuel available when this engine was designed in 1994, without that natural sulfur lubrication. The friction between the steel plunger rod and the camshaft lobe skyrockets. The hardened tip of the plunger rod begins to wear down, turning into a sharp chisel. Slowly, it grinds away the actual lobe on the engine's camshaft. As the cam lobe wears down, the pump loses its stroke length. Your fuel pressure drops from the factory-specified 60 psi down to less than 30 psi under load. This starves the single-shot injectors, causing internal fuel cavitation that destroys the injector intensifier plungers. Worse yet, the metal shavings ground off the camshaft lobe drop straight into your engine oil, traveling directly toward your main crankshaft bearings. Replacing a ruined camshaft requires a complete engine teardown down to the bare block. You are looking at $5,000 in parts and machine shop labor for a problem caused entirely by a dry fuel delivery design. The immediate fix: if your OBS truck exhibits a soft, lazy throttle or struggles to maintain speed on hills, check the fuel pressure at the fuel bowl test port using a mechanical gauge. If it reads below 45 psi at idle, your mechanical pump or plunger is failing. Do not just buy another mechanical factory replacement pump. Permanently eliminate the problem by installing an electric fuel conversion e-fuel kit. This modification removes the mechanical pump and plunger entirely, seals the hole in the engine block with a plug, and utilizes a frame-mounted electric pump to deliver a constant, safe 65 psi of fuel pressure regardless of camshaft condition. The hidden traps built into these early generation configurations run deeper than simple fuel delivery issues. And what happens inside the transmission bell housing of the automatic models is even more severe. -4. The torque shift illusion and the flex plate shear. If you opted for a late generation 7.3-liter Super Duty equipped with the 4R100 4-speed automatic transmission, you were told you bought a commercial-grade drivetrain. The marketing literature claimed this transmission was an evolution of heavy-duty engineering designed to handle maximum towing capacities without complaint. That narrative is a dangerous illusion. While the internal gear sets of the 4R100 are reasonably tough, Ford left a catastrophic weak link exactly where the engine's crankshaft meets the transmission input shaft, the torque converter flex plate, in a heavy-duty diesel application. The flex plate must endure massive torsional firing pulses from the engine's pistons. Because a diesel operates at high compression, each combustion event hits the crankshaft like a sledgehammer. To save manufacturing costs, Ford used a stamped steel flex plate that is far too thin for the weight of the trucks they were building. When you install a modern performance tuner or chip on your 7.3, which increases torque by up to 150 pound-feet instantly, the stress on this stamped metal disc exceeds its structural yield point. The metal begins to work harden and develop microscopic stress fractures radiating outward from the crankshaft bolt circle. Slowly, over thousands of miles, these cracks connect. The first symptom you will notice is a strange metallic ticking sound at idle that mimics a bad lifter or a loose exhaust manifold. Eventually, under heavy load or acceleration, the flex plate suffers a catastrophic structural shear. The center of the plate completely rips away from the outer ring. Instantly, you lose all propulsion. But the damage does not stop there. The liberated outer ring spins wildly inside the bell housing at 2,000 RPM, shredding the aluminum transmission case, destroying the front pump assembly, and slicing through the transmission cooler lines. A simple $80 metal plate failure instantly transforms into a total drivetrain disaster. A flatbed tow, a replacement transmission assembly, and a new torque converter will cost you upward of $4,500 at any reputable shop. The immediate fix: if you hear an unexplained metallic clicking or rattling from the bottom of the engine bell housing, stop driving immediately. Remove the rubber inspection cover on the bottom of the transmission bell housing. Manually rotate the engine crankshaft with a breaker bar and use a bright flashlight to inspect the metal surrounding the torque converter mounting bolts. If you see any black lines or hairline fractures, do not wait for it to explode. Replace the factory unit with a heavy-duty SFI-approved forged steel aftermarket flex plate. These are twice as thick as the OEM factory component and are designed to handle over 1,000 pound-feet of torque without cracking 5. The ultimate deception. The air filter box block destroyer. We have arrived at the single most deceptive, destructive, and widely overlooked design failure in the entire history of the 7.3-liter Power Stroke engine. This is the flaw that has killed more million-mile motors than every other mechanical failure combined. It is not an internal component. It is not a high-pressure oil pump, an injector, or a computer module. It is a cheap plastic box sitting right in plain sight on the driver's side of your engine bay. The factory air filter housing assembly on the 1999 to 2003 Super Duty models. The corporate engineering behind this airbox is nothing short of criminal. Ford designed the housing with a two-piece plastic clamshell lid secured by basic metal clips. The intent was to make filter replacement fast and simple for consumer maintenance. However, they utilized a soft, flexible plastic compound that cannot withstand the intense heat cycling under a truck hood combined with the immense vacuum pressure generated by a 7.3-liter turbocharger pulling air at full load. Over time, the plastic housing warps and distorts. The flat sealing surfaces where the air filter element is supposed to seat tightly against the box become curved and uneven. Even if you install a brand new, premium OEM air filter, the warped plastic prevents the lid from sealing correctly. A visible gap, sometimes less than a millimeter wide, opens up along the back and sides of the filter housing. Because a turbocharger is essentially a high-powered vacuum cleaner, it takes the path of least resistance. Instead of drawing air through the restrictive paper media of your clean filter, it pulls raw, unfiltered ambient air straight through those warped plastic gaps. If you drive through a construction site, down a gravel road, or through a dusty agricultural region, your engine is actively inhaling raw dirt, silica, and debris directly from the atmosphere. This process is known in the diesel industry as dusting. When abrasive silica dust enters the intake tract at high speed, it hits the compressor wheel of your turbocharger first. The dust acts like a high-velocity sandblaster, eroding the leading edges of the aluminum compressor blades until they are rounded, chipped, and completely useless. But the turbo is just the first victim. The dust passes through the intercooler and travels directly into the engine cylinders. Inside the cylinders, the silica mixes with the engine oil on the cylinder walls, creating a highly abrasive grinding paste. Every single stroke of the piston forces this grinding compound against the piston rings and the cast iron cylinder walls. Within a matter of weeks, your compression rings are ground down to nothing, and your factory crosshatch hone marks are erased from the cylinder walls. The engine loses compression across all 8 cylinders. It begins blowing massive amounts of crankcase vapor out of the oil fill neck, a condition known as severe blow-by. The truck becomes incredibly difficult to start, burns oil at an alarming rate, and loses half its horsepower. The ultimate deception is that the truck will run completely fine while this destruction is actively occurring. You will look under the hood, see a clean airbox, and assume your engine is perfectly protected. By the time you notice the performance loss and the heavy smoke, the internal mechanical damage is already 100% irreversible. A ruined turbocharger and zero compression cylinder walls mean your unkillable million-mile motor is completely dead. There is no quick fix, no additive, and no magic oil that can restore worn iron. Your only option is a complete engine extraction, boring out the cylinders at a machine shop, and installing oversized pistons and new rings. This is a $9,000 to $11,000 catastrophe caused entirely by a warped $20 plastic lid that looked completely fine from the outside. The immediate fix: stop what you are doing, go out to your truck, and pull off the intake tube leading from the airbox to the turbocharger. Take a clean white paper towel and wipe the inside of the aluminum turbo compressor inlet. If you find even a microscopic of fine dust, black grit, or grimy residue, your airbox is leaking and your engine is actively being destroyed. Do not buy another factory airbox replacement. Throw the entire plastic assembly into the trash immediately. Install a high-quality aftermarket cold air intake system that utilizes a completely sealed rotomolded housing or a heavy-duty multi-layer dry cone filter secured tightly to the intake pipe with a rugged steel T-bolt clamp. This creates an airtight seal that completely isolates your intake tract from raw atmospheric dirt and guarantees your engine actually lives to see its million-mile milestone. The final warning: the execution plan. The market is flooded with sellers who are trying to unload these trucks the exact moment these hidden flaws catch up to them. They will clean the engine bay, clear the diagnostic codes, and wait for an unsuspecting buyer to hand over $6,000 for a truck that is on the verge of a mechanical breakdown. If you want to protect your investment, stop listening to the internet myths and start acting like a technician. Memorize this definitive defense checklist before you ever look at another auction listing or online ad. Test the coolant chemistry. Prevent the cavitation erosion hole by verifying CADCA4 levels with fleet testing strips, or draining the system for an EC1 compliant extended life coolant (EL). Inspect the valve cover connections. Eliminate dead misfires and fried PCMs by replacing degraded internal harnesses or implementing the mechanical coin locking fix. Isolate the fuel bowl circuit. Protect your computer from sudden highway shutdowns by pulling the plug on the failure-prone fuel heating element and keeping a fresh 30-amp fuse in slot 22. Seal the exhaust up pipes, restore lost boost pressure, lower your exhaust temperatures, and save fuel by swapping leaking factory crush donut joints for stainless steel bellowed up pipes. Protect low-pressure lubrication. Prevent hydraulic injector starvation by monitoring hot oil pressures and replacing worn front Giro pumps before cavitation ruins your top end. Verft HPOP reservoir levels. Stop destructive dry cold starts by checking the overnight oil drain back level and rebuilding the anti-drain back check ball seat assembly. Check for coolant contamination. Save thousands in unnecessary head gasket repairs by isolating fuel and coolant leaks down to cracked brass injector cups and renewing them with high-strength retaining compounds. Seal the oil pan. Bypass a mandatory 15-hour engine extraction labor charge by treating oil pan corrosion early with rust converters or multi-layer structural epoxy patches. Convert to electric fuel, OBS models. Eliminate camshaft lobe, grinding and low fuel pressures on 1994-1997 trucks by bypassing the mechanical lift pump with a modern frame-mounted e-fuel conversion kit. Check the flex plate integrity. Avoid total transmission case destruction by removing the bell housing inspection cover and checking for stress fractures around the crankshaft bolts. Deed, the factory airbox. Prevent terminal cylinder dusting by checking the turbo inlet for dirt film and replacing the warped factory clamshell housing with an airtight, clamped aftermarket intake system immediately. The Ford 7.3-liter Power